But do you know this river can generate electricity?
Oh yeah, how is that?
Okay, let me show you.
Hi! You want to know how river generate electricity? But before that, can you hit the button like and share? Done? Thank you! So, let's see how this process begins.
The history of hydropower. In the Middle Ages, water mills powered sawmills and textile production, laying the foundation for industrial energy use. The Industrial Reduction saw the first hydropower turbines in the 19th century, transforming rivers into source of mechanical energy. By the 20th century, large dams like the Hoover Dam emerged, producing electricity for millions and advancing renewable energy. Today, hydropower provides 60% of the world's electricity, paving the way for a sustainable future alongside other renewable sources.
River can generate electricity? This process called as hydropower. Hydropower is a way of making electricity using an energy of flowing or falling water. This is dam. Dam is built on a river to store water in reservoir. When water is released, it flows through turbines which spin and power generator to create electricity. Do you know that this process produces clean and renewable energy without polluting the air? So that's good, right?
So next is the classification of hydropower. Classification of hydropower has two types. First is the run-off river, and the second is pump storage hydropower. What is different for these two? Let me explain one by one. For the run-off river, systems harness the natural flow of rivers to generate electricity. They don't require large reservoirs, but use small dams or diversion channels to guide water through turbines. Next classification is pump storage hydropower. So on the other hand, it's a form of energy storage. So it uses two reservoirs at different elevation. During low demand periods, surplus energy is used to pump water uphill. And during peak demand, the stored water is released, flowing downhill through turbines to generate electricity. So the pump storage offers greater control and can respond quickly to energy demand.
The first one is the reservoir. Reservoir is a storage area for the water collected behind the dam. It maintains a high water level to ensure a consistent flow into the intake. Then, we're focusing on the intake. Intake controls the flow of the water from the head pump into the penstock. It has screens or the gates to regulate water entry and prevent debris from entering. Then, the water flowing to the penstock, a spout that channels water from the intake down to the turbine. It is increasing the potential energy as the pressure exists. The next part is the turbine, where the high pressure water from the penstock strikes the turbine blades and causing it to spin. In here, kinetic energy is converting to the mechanical energy. Tail race, a channel that carries water away from the turbine and returns it to the downstream river. Then, generator. Generator and turbine are connected. By rotating the generator's rotor, the turbine transforms mechanical energy into electrical energy via electromagnetic induction. Then, it reaches transformer, which transforms the generator's electricity into a greater voltage so that it can be sent over long distance. The last one is the transmission line, high voltage power lines that carry the electricity from the power plants to home, business, and other end users.
Now let's talk about how amazing the hydropower. First, it's reliable and consistent. Like a faucet, you can turn on and off. Hydropower provides steady electricity by controlling water flow, so it's always ready when we need it. Next, it's super efficient. Over 19% of the energy in moving water become electricity. That is way more than most energy sources. It's also clean and green. Hydropower doesn't burn fuel, so it's hardly produce any greenhouse gases, which means it's good for us and the planet. And finally, storage capacity. Hydropower reservoir act like giant batteries, saving energy for when demand is high.
I'm still don't understand yet.
You don't understand? It's okay. How about we put them together? Let's go.
Now, let's look at our model. First, we have reservoir. This is a dam. And also, we have a powerhouse which contains three important parts, which is turbine, generator, and transformer. This transformer connected the line to our transmission tower.
For the working principle, let's sing together.
Hydropower flowing strong in the dam where you belong. Water store up high and still, waiting till it drives the mill. Hydropower flowing strong, turning water into glow. Open gates and let it go. Through the pipes it starts to flow. Down it rushes fast and free, turning turbines with great speed. Hydropower flowing strong, turning water into glow. Turbines spin, the magnet turn, electric power we earn. Generators hums away, making power every day. Hydropower flowing strong, turning water into glow. Transformers that voltage high, sending power through the sky. High it travels far and wide, reaching town on every side. Hydropower flowing strong, turning water into glow. Once it's done, the water flow back to river down below. Clean and green, a steady force, helping us along its course. Hydropower flowing strong, turning water into glow, turning water into glow.
Up next, we bring you the latest news on.
Assalamualaikum. Welcome to our live broadcast, where we spotlight the environmental effect of hydropower. Hydropower is a vital renewable energy source supplying clean electricity to millions. It significantly reduces greenhouse gas emission, making it an essential tool in combating climate change. But what about its effects on our environment? Building large dams disrupt river ecosystem, blocking fish migration and altering aquatic habitats. This leads to reduced biodiversity and impact fisheries. Flooding for reservoirs submerge vast area of land, displacing local communities and wildlife. Additionally, decomposing organic material in reservoirs can release methane, a greenhouse gas more potent than carbon dioxide. While hydropower is a critical energy source, its environmental and social costs highlight the importance of thoughtful planning and impact mitigation. Stay tuned for more insight. This is Aina signing off from today's Eco Spotlight.
Inak Pat.
أعوذ بالله من الشيطان الرجيم وأنزلنا من المعصرات ماء ثجاجا and we sent down from rain clouds pouring water.
From Surah An-Naba, verse 14. This verse highlights the phenomenon of rain as a sign of Allah's power and mercy. The pouring water not only sustains life but is also integral to modern technologies like hydropower. Hydropower harnesses the movement of water typically from rainfall-fed rivers and dams to generate electricity. This demonstrates how Allah's blessings like rain can be transformed into beneficial resources for humanity.
Oh, like that. Thank you, my sister.
It's okay, no problem, Asha. It's already late. Let's go.
Let's go.
Thank you for watching. Bye.